Hey guys, what's going on? It's me, Keenan, and today I'm going to be answering some questions about my previous ghost video. So after I uploaded the video to YouTube, I took like a 30-second snippet of it and posted it in a few subreddits. Some of the users' responses mainly consisted of, hey, how does this circuit work? And hey, how did you program it? Or what software did you write? And they really wanted me to share it and get into it. So today in particular, I figured we could go through it step by step. Now, originally I did plan to put the software into the first ghost video. However, I just figured many viewers would find it boring. Since I did receive requests though, I went ahead and made a pictograph using fritzing, and no, it's not a schematic for those circuit specialists out there. I get it, it is different than a schematic. However, for people new to Arduino, it's very helpful to just visually see, and for those visual learners, what's going on the circuit. So I'm going to be going over that today, and I also took out a lot of the code, or simplified it, if you will, to where it was easier to explain and easier to receive as a message. Before we jump into the pictograph, I just want to say if at any point you get lost or confused throughout the video, pause it real quick and drop a question in the comment section. Otherwise, I'm not going to be able to help you. And ask other users as well. I'm not the only one that's ever worked with Arduino, so they may have a better solution for you or an easier way of explaining it, but I will do my best. So let's go ahead and jump in now. Alright, so here we are in the fritzing app, and I have the circuit pulled up in front of me. So let's go ahead and get started with it. Now, one thing I do want to mention is that you're not going to be able to see my cursor throughout this part of the video, but you will be able to see when I hover over something. So starting out down low, we have the Arduino Uno Rev 3. Okay, we've got the serial MP3 module on the right, a servo motor up in the top left, and those are really the only modules we'll be using. The first step we want to do is take power from the power portion of the Arduino and run it into the bottom left corner of the breadboard. So you've got your power is your red wire, your negative or neutral is your black wire. Okay, and after we've done that, we want to come over to the bottom right corner and jump that power and ground over to the opposite side. Now these wires don't have to match exactly. You can use jumper wires. Those work just as well. And after we've done that, let's come up to the top left corner where we're going to install the servo motor. Now keep in mind your servo motor is going to have different colored wires. However, the pinout should be the same. It should have a ground or neutral, a 5-volt or positive, whatever you want to refer to it as, and then a communications line. In this case, the pictograph has it as yellow. Now this will be connected coming down here to pin 9 of the Arduino, and that's what we're going to attach our servo to so that we can send commands. Besides that, coming back up to the top left corner, you have it grounded out, and you also have power coming to it. Now I have a capacitor attached. Some people say that it's not needed. I like to put it there just in case. And do keep in mind, the capacitor will have a stripe on one side of it, either side, right? And it should be your negative side. So line that up with the other ground wires. You can see here, if we look at this black one here, it comes down vertically. And it lines right up with the capacitor, where it's got that blue kind of tint on the corner. You can kind of hardly see it. After we've done that, let's jump to the buttons in the middle. And we're just going to go over one of these because you can really mimic it 2 more times. So here we have the button attached. We've got power coming in from this red wire. We've got the green wire waiting for a break in the circuit to send a signal. Okay, and these are going to be attached to pins 4 through 2. So we've got the one starting out at 4 right here. Okay, we've got our 10K resistor. And we've got the gold ring facing outwards. And we're just going to do that 2 more times. So don't get lost there. Okay, refer to the pictograph if you need it. And then we're going to come over to this LED. Now this is totally unneeded. You do not have to do this. This is only if you want it. This is for me a code check, as it allows me to know for sure that these buttons have been detected as being pressed. Because when they are, this LED will light up letting me know. So we've got pin 8 here, which is providing power to the LED whenever one of these buttons is pressed. And we'll go over the code of how it does that later. But behind that, we have the 220 ohm resistor with the gold ring facing out. And that pretty much sums it up for this top half. Now we're going to come down to the serial module and the bottom half. Now the serial module here in Fritzing is nothing like mine. It has 2 more connection pins here, and it does not look the same. So I'm not sure what type of module this is, but just know yours probably differs than mine, and it probably differs from the one we're about to go over. So do reference your own personal data sheet from the manufacturer. Now in my case, this one has a RX and a TX pin, and then a 5 volt and a ground. So my RX and TX stands for receiving and transmitting, and that's what allows the serial communication to take place between this module and the Arduino Uno. It's needed to send commands as it has serial commands of its own on the data sheet. And I'll show you which one I have. I do not have an Amazon link or anywhere where I got it because I'm not certain exactly where it came from. I just bought it from a buddy of mine. So if I do find it, I will link it in the future. Or if you guys know where it originates from, please do drop that link in the comments. I do thank you. But the first thing we're going to do is determine which of these pins, 6 or 5, we have determined to be the RX and TX pins. And we're going to set those up in the code. So we can say, hey, pin 6 here is going to be the receiving end, and pin 5 is going to be transmitting. So let's say we did that, right? Pin 5 would be transmitting. So it's going to come up and come to this bottom yellow wire here, which would be receiving. So we want TX to RX and RX to TX, right? That way we have a loop. So that pretty much sums it up for the schematic here. And we're going to jump next into the software and see how it works alongside this pictograph. Before we hop into the software part of this video, I just want to stop and say if you're enjoying it this far, make sure to leave a like and a comment below. I want to connect with the community and see what you guys are working on, what projects have interested you, and consider subscribing. But without further ado, let's get into the software. Now that we have seen the pictograph and we have seen the physical model of the circuit, we're going to run through the software. The first thing you're going to want to do is include both libraries that we're going to need. We have a software serial for communication and a servo for sending the commands to it. Below that, we're going to define constant variables. Here we have the Arduino receiving pin or RX pin. The value is pin 5. That's what we set. We're going to need these so that when we reference the new serial port for communication on the YX5300 and the Arduino, right, we're going to need these. We're setting this port. This port does not exist unless we set it up. So up here we've done that. My data sheet for my module, your modules are probably going to be different, but my data sheet has these commands. These are the name of the commands. These are the values held in them. I'm already defining those. So below that, I create a new instance of servo, my servo, so that we can reference this later. Coming down, we have a bunch of integer variables here. Servo angle, start position, right? So 82 degrees is my start position for my servo because it's equivalent to 90 degrees. We have switch state 1, 2, and 3. These hold and stow away the state of the buttons. Below that, servo angle serial is holding the value myservo.read. So whatever value this brings back is going to be stowed in here. One more static integer variable created, and this is for 8 bits of memory. This is going to be used in the method at the bottom of the software that you will see in a minute. Again, this is particular to my module. Yours may be different. In the setup, we have my servo. Remember how we attached it to pin 9 of the Arduino? Right there. There it is again, pin 9. My servo.attach pin 9. Very straightforward. Sets the servo to start position, angle 90, which remember, mine was 82. So my servo.write, immediately off the bat, let's set it at 90. We're going to do pin modes for 4, 3, and 2. These are our buttons, and they are inputs. We're waiting to receive something from them. Pin mode 8 is the LED. This is optional. You do not have to have this if you do not want it. We're going to open communication between the computer and the YX5300 module or the serial MP3 module so that we can send commands to it as well. My serial.begin 9600, that is the speed at which it will communicate. And we're going to delay a second so that the micro SD card can be initialized. Here, we're going to send a command, right, to select the micro SD card and initialize it. Wait 200 more milliseconds. In the loop, these are constant if-else statements. These are very easy. I'm not going to go through all three of them. They are literally copy and paste. Switch state 1 is equal to digital read 2. It's reading that second pin, waiting to see if the voltage level changes. If it changes and we have clicked it, it will be set to high. If it's high, then we want to digital write out to pin 8 to set high. That cuts the LED on. Remember, we connected pin 8 to the LED. Send command, play with volume, 0x0f. This is one of those constants defined above, right? Select which file we want to play. We want to play 009. So in the micro SD card, my MP3 files are labeled as 009.mp3. And remember, that is particular to my module and my data sheet. Yours is probably different. After that, my servo.write, this is what makes it move. Wait a second, write again. Wait 3 seconds. We wait 3 seconds because that's how long this first MP3 file is. And then if it's not been clicked, we can probably just use else. You don't have to do an else if. You can just do else, switch state 1 is equal to low, digital write 8 low, the LED is off, so LED off. Right there. My servo.write, set it back to the original start position. Copy and paste. Boom, boom. That's for all three of the buttons. Down here is the method I was telling you about. This is particular to my model as well. It builds the 8-bit command that it needs in serial form so that it knows what to do. This is always the starting byte for mine. This is the version. This is always this. The command variable is the one that differs, right? So that's the one I'm giving it, command. And then I'm also giving it this here, 5 and 6. And it builds it, ending byte, and then it sends it as a whole. Alright guys, thank you so much for watching today. And if anything, before you click off the video, make sure to leave a like and consider subscribing. You're not going to want to miss this next video.